The demonstration today is turning a natural edge bowl from green wood. To better understand the fun and challenges of working with green wood, we need to consider the structure of the wood. Wood is made of fibers that show up clearly in the red oak rim of this segmented platter. When the tree is growing rapidly in the spring, the fibers form hollow tubes that transport sap between the roots and leaves. When growth slows down in the summer, the fibers form a dense layer that provides strength to the tree. The wood fibers are like elongated ovals, long, fairly wide, but not very thick. While the tree is living, these fibers are fully saturated and contain about 30% water by weight. The tubes are filled with sap and can add another 30 to 50% to the moisture content of the wood. The wood is then said to be green. Green wood is soft and cuts very easily, but sap is slung out of the fibers while turning, so it is very messy, and the turner should plan on getting soaked. When the tree is cut, sap is lost from the tubes until the fiber saturation point is reached around 30%. But the fibers don't change shape until the fibers begin to lose moisture. They do not shrink in length, but they do shrink more tangentially in width than they shrink radially in thickness, so flat sawn boards tend to cup as they dry. This bowl lost 44% of its weight from when it was first turned until it was fully dry about 2 months later. It shrank 10 millimeters in width, going from 259 millimeters to 249 millimeters, and this can be seen very clearly on the rim where the inner and outer circles are drawn. The shrinkage is also apparent in the way the bowl rocks on its rim. For a flat-rimmed bowl, the wall thickness should be about 10% of the diameter, so after drying, there will be enough wood to create the desired design for the rim. As long as the wood is straight-grained and clear, the shrinkage is predictable. But when there are differences in the wood structure, like the cherry root that yielded this little bowl, the resulting shape is always a surprise. As wood turners, we don't want our turnings to crack, and there are several things we can do to minimize the risk. The first is wood selection. Each species has its own tangential factor for shrinking around the circumference and radial factor for shrinking in diameter. The more they differ, the greater the risk of cracking. This chart shows the tangential to radial shrinkage, so you'll be safe if you choose magnolia for turning, but watch out if you try to turn striped maple. On the club website, there's a link to the article that lists the shrinkage factors for 80 common species of wood. Crabapple has a tangential to radial ratio of 1.8, which is very similar to cherry, but its values are 10.1% and 5.6% compared to 7.1% and 3.7% for cherry. This means that there's a lot more movement of the wood as it dries. There's no way I could have avoided the cracks from the branches of this bowl I turned from a crabapple crotch. The first tools I bought were made from high-speed steel by various manufacturers. When I bought my 3/8" Pro PM gouge by Crown Tools, I was impressed by how easily it could be sharpened, how well it held an edge, and the handle was very comfortable for me. The Crown Tool website describes the tools this way. Made from an advanced powder metal, the molten steel has been compressed and sintered, giving Pro PM turning tools a cutting edge which lasts up to 4 or 5 times that of a conventional high-speed steel tool. The chisels are hardened to between 66 and 68 degrees Rockwell, enabling the tools to have a vastly superior wear resistance, excellent grindability, superior toughness, a high working hardness, and a high retention of hardness. I now have 6 Pro PM tools and turn with them 95% of the time. I am most comfortable using push cuts while turning bowls, so my tools are ground accordingly. I sometimes make pull cuts with an Ellsworth grind gouge when I'm working on the rim of a bowl with an enclosed form. I use this 1/2" bowl gouge for removing the bulk of the wood while forming the exterior and interior profiles. The bevel angle is 45 degrees and the tip is asymmetrical. The left wing is swept back a bit, so there's a fairly long edge for making a shear cut. The right wing is almost square, so it can make a wide, deep cut and hog out a lot of wood very quickly, only limited by the horsepower of the lathe. The 3/8" gouge is my go-to tool for making finishing cuts on the exterior and interior profiles. The wings are fairly short, so there's a relatively long sweet spot for taking a light shear cut. The bevel angle is 40 degrees, which makes it possible to make the final cut from the rim to the center on all but the deepest bowls. I use this 5-inch Vicmark chuck with dovetail jaws on any turning that has a tenon. I don't bother to try to match the diameter of the tenon to the exact diameter of the chuck when it is fully closed, because it takes me too long to make those precise cuts. Instead, I make the tenon as large as possible and let the 8 corners of the chuck segments dig into the tenon, which provides a very strong grip on the tenon. I never incorporate the tenon in the foot design anyway, so the damage doesn't matter. I've never had a catch that knocks the blank completely out of the chuck, but I have had bad catches where the blank is twisted in the chuck or the tenon has broken off completely. However, I have had blanks fly off when using a different lathe with a chuck with ribbed, straight gripping surfaces. There are 2 other chucks that I will be using during this demonstration, but I'll describe them in more detail later on. The first is a custom-made 1 3/8-inch pin chuck that I use for turning the outer profile. The second is a vacuum chuck that is used when the tenon is removed and the base of the foot is finished. Tool rests need to be in very good condition because if there's any roughness, tools will not glide easily and defects will be transferred to the workpiece. My favorite is the robust low-profile tool rest, which has a very hard, polished drill rod welded to the top of the rest. I usually hold the fingers of my left hand tightly against the rest and use them as a depth gauge for the tool. I also have a standard robust tool rest, but I only use it when I have to turn left-handed. With its large face, I can support my full right hand in the face of the tool rest. On the other hand, using the straight tool rest is also a challenge because the tool overhang is constantly changing and the tool becomes unstable when it is nearly parallel with the rest. A curved bowl rest is fine for cutting the outside profile of a bowl, or when I have to use a scraper on the inside of the bowl. If I use my 3/8-inch bowl gouge for a long finish cut on the inside, the difficulty is that the pivot point of the tool is constantly changing. I usually end up using the straight tool rest and adjust it several times and carefully blend the individual segments so there are no bumps in the final surface. This is the approximate profile of the bowl I will be turning today. The log section is about 12 inches long and 10 inches in diameter, so the resulting bowl will be nearly round. I often make the length about 1.5 times the diameter of the log. If it is much longer, the bowl looks more like a tray. This style of foot looks best when its diameter is about 1/4 of the length of the bowl. I like a profile that is slightly concave near the foot and convex at the rim, and joins the rim at a 45 to 60 degree angle. This open form is easy to turn and sand. Like any turning project with interesting wood, the wood influences the final form because there may be a defect that needs to be removed or a special grain pattern or color that can be emphasized. If you look at the profile and think of the blue lines as the soft spring wood fibers, you see that these weak fibers are supported by the strong summer wood fibers when the outer profile is cut from the foot to the rim and the inner profile is cut from the rim to the foot. This minimizes the likelihood of tear out, although twice on every revolution of the blank, the cut goes from end grain to downhill to long grain to uphill. To minimize tear out, sharpen your tool before you make the final finish cut. Whenever we are turning, our number one priority must be safety, our immediate safety, our long-term safety, and the safety of everyone else in the area. These are the safety items I always use when I am turning. Since loose clothing, jewelry, and long hair can be potentially dangerous, I always wear a pullover or smock with tight-fitting cuffs and a collar that closes around my neck to keep chips out of my clothes. I normally wear a smock, but since I'll be working with green wood today, I'm wearing this pullover that has already been stained by oak and walnut sap. As you can see from the wall in back of my lathe, I have turned a lot of green wood. A cap keeps chips out of my hair, and I use a full face shield to protect my face and eyes from sap, chips, and possible flying chunks of wood. I always wear ear muffs to filter out the loud, high-frequency noise of the wood being cut. This allows me to more easily hear changes in the sound of the tool as it cuts that might indicate cracks that are developing, soft spots, and other defects in the wood, or a clicking noise if the tool strikes an embedded nail or stone in the wood. That's always a possibility when you are turning wood from a backyard tree because it once may have held a clothesline, swing, or hammock. Filtering out the loud, high-frequency sounds also minimizes your risk of long-term hearing loss. And finally, I wear gloves to protect my fingers and hands from being stained by sap, especially if I'm turning green walnut or oak. And when I'm taking heavy cuts in dry wood, the cutting tools can get quite hot, and the gloves protect my fingers from possible mild burns. And now it is almost time to begin the fun part of this project, turning. But first, the blank has to be prepared using the bandsaw, the most dangerous tool in my shop. Every time I use the saw, I think of the many times I have seen the butcher at Kroger's use a bandsaw to quickly cut up a big piece of meat and realize that I could cut off a finger in less than a second. To be safe, the bandsaw should be properly tuned, sharp blade, proper tension, and blade guides properly adjusted. I have this tape on the table of the bandsaw to remind me of the danger zone where I should never have my fingers, hand, or arm, and the upper guide should be set as low as possible. Cutting round wood is always dangerous, but sometimes it is necessary. To minimize the risk, I use corners cut from a blank to shim and stabilize the round wood. We had very strong winds in Lewisburg a week ago, and a neighbor's flowering crabapple tree blew down, and I was asked to turn a memory bowl from one of the branches. I cut a slice off the end of the log, and it offers some interesting challenges. There's nice contrast between the heart and the sapwood, but the pith is way off center, so there's a lot of reaction wood that may twist and crack during drying. There are a few checks coming from the pith, and I will try to eliminate them as much as possible and use thin CA glue to stabilize the ones that remain. I'll rip lengthwise along this line so the pith will be in the tenon. There are interesting ribs on the left side that would make an interesting rim, but that side of the log is too thin to turn. The most dangerous step in preparing the turning blank is splitting the log through the pith. The only safe way to do this is to use wedges and a splitting axe, but this leaves a very rough surface, which makes it difficult and sometimes risky to saw a round blank for turning. Large pieces can be cut with a chainsaw, but it's often difficult to stabilize a round log so that it doesn't move while you are cutting. But if the log has to be cut off center, the blade will tend to rotate the log, which can be very dangerous. The log can be stabilized by screwing a board to it and provide a stable surface. Before you split the log, you need to consider all the risks and advantages of each approach and decide the method that you think will be safest. Logs less than 10 inches in diameter can be cut on a bandsaw, and if the log is being cut directly through the pith, the blade is pulling the log directly down on the table. I chose to saw the log for this demonstration freehand since I will be cutting directly through the pith along the center of the log. I've set up the bandsaw to rip the log lengthwise, so here we go. The next step is to cut a round blank from the split log. I've cut discs of different diameters from the stiff plastic and tacked the one with the best fit to the log and will cut around the disc. I usually choose a disc to give a blank with a length equal to between 1 and 1 1/3 times the width of the log. Since this log is about 8 inches in diameter, I've tacked the 10-inch disc to the log and will proceed to cut around the blank. Since I use a custom pin chuck for blanks less than 12 inches in diameter, the next step is to go to the drill press and drill the hole that will align the bowl. I like to use a metric tape measure because I find it easier to compare millimeters rather than use measurements from a standard tape measure with quarter, eighth, 16th, and 32nd inch markings. Okay, the first thing I want to do is make sure that the blank is aligned lengthwise. I checked the measurements about 115 millimeters on both sides, so that's centered lengthwise. I next checked the height of the blank. It's about 105 millimeters on both sides, so that means that with the finished bowl, the two ends will be at the same height. If one end were low, I would shim that end so that they would align properly. The next thing is to check the depth that I'll be drilling the hole. I'll be going approximately, looks like around 50 millimeters or so, so I'll set the depth gauge on the drill press and be ready to go. The final step is to check to make sure that the blank is aligned widthwise. So I will verify that now it's about 75 millimeters on both sides. So that means that it's aligned lengthwise and widthwise. So now the last thing to do is to turn on the drill press and drill the alignment hole. For small bowls less than 6 inches in diameter, I normally just use a piece of nail to lock the blank onto the pin, but I use lag screws for larger blanks like this one. With the chuck and blank attached to the lathe, it's time to get started. My lathe came with a single-speed motor and a 4-step pulley. I replaced the standard motor with a variable speed DC motor, but it does not have a digital readout. With a 10-inch blank, the safe speed range would be 600 to 900 RPMs. So I have set the drive belt on the 875 RPM step. Lower speeds are safer since the kinetic energy of the rotating bowl increases with the square of the speed. If you increase the RPMs from 500 to 1000, the bowl has 4 times the kinetic energy if it were to fly off the chuck. Use the tailstock with a live center whenever possible to minimize the possibility of the bowl flying off the chuck if you get a bad catch. With the tailstock in place, I will turn the blank by hand to be sure it doesn't hit the tool rest. Then I will start the lathe at the slowest speed and increase it slowly until the lathe begins to vibrate or it gets to the desired speed. Blanks that were trimmed with a chainsaw are usually out of balance, so it is necessary to turn off the high corners, increase the speed, turn off some more, and then repeat until the lathe doesn't vibrate at the desired speed. As you can see, the pith is down here a ways into the bowl, and there's a number of checks that are developing around that pith. So what I'm going to have to do is cut off this part of the base here and cut off probably about 3/4 of an inch, make the whole bowl a little bit shallower. So that'll be the next thing, will be to clean up this end and get rid of those checks in the pith. Still need to come off a little bit more. It's not great, but I'll start working again on that. Okay, now I'm going to clean up the tenon area on this. And now I'll finish up the outer profile. Still needs to come off a little bit more here at this end. Now that the outer profile is complete, I can either take a break or continue turning. If I continue turning, I'll remove the chuck using the spanner wrench, which makes the job very, very easy. But if it's time for a break, I'll remove the chips from the lathe bed and spray it with WD-40 to protect the bed from the corrosive sap. I'll wrap the partially complete bowl in a plastic bag so the end grain doesn't begin to dry and check. This is especially important if you're turning green cherry. One of the challenges of turning a natural edge bowl is knowing where the edge of the rim is. Otherwise, you might hit it with your knuckles or tool. A piece of white or colored material on the lathe bed makes it easier to see the edge. I'll be cutting downhill from the rim towards the center. Each pass will be about an inch deep, so I will be making several passes. Since you're cutting a lot of air at the ends of the bowl, rubbing the bevel on the wood is impossible, so you need to approach the edge with the bevel parallel to the outer profile and at the optimum cutting angle. For my 3/8 inch gouge, this is the position the tip needs to be in when the tool first meets the spinning edge. And now for the final pass. Now that the turning is complete, there are two more steps that must be taken. The first is to weigh the bowl while it is green so the drying process can be monitored. It now weighs 403 grams, and over the next couple of weeks, the bowl will lose about 40% of its weight, or about 160 grams in all. The last step is to dry the bowl. To do that, I'll wrap up the bowl in several layers of newspaper so that the newspaper will absorb the water as it evaporates and keep the entire bowl at a uniform moisture level. If the moisture level is different in different parts of the bowl, then there's always the risk that there's going to be cracking that's taking place. But I've had very good luck with the newspaper method of drying. So I'll take the bowl, I'll put it in a cardboard box and stuff a little bit more newspaper around it. And then I'll set it aside and monitor it on a daily basis.